Let's take a look at an example of how we can use the chain rule and a table of values that were given to find requested derivatives. So if you take a look at this table, we have two different x values, 2 and 5, and it seems like we're dealing with two functions, f and g. We have the function values for those two functions as well as the derivatives. Now this last one didn't show up over here, I just noticed. This should be a square root of 2 right there, just so you know. So what we're going to be asked in each of the following problems, there's 3 problems we're going to look at, is to find h prime of 2 specifically. Okay, so keep that in mind. So the first one we're asked to do is when the function h is defined to be the composite function f composed g, f of g of x. Now, because it's a composite function, if we wanted to find the derivative of h, that's going to require us to do the chain rule. So remember how the chain rule goes. We start on the outside and we work our way in, taking one derivative at a time. So the outside function in this case is f. So we're going to start with f prime and we're going to keep the g function as it is, remember. And now we have to go inside. We're going to have to take the derivative of the g function and just multiply by g prime of x. Now remember we specifically wanted h prime of 2 to be found. Alright, so let's just make this easy. Fill in our 2's for our x's. And then we should be able to use the table of values to finish this off. Alright, so let's start with this inside right here. G of 2. So if you take a look at the table, G of 2 is 5. So that means we have f prime of 5. Before I forget, don't forget this value over here. For some reason, that's the one that didn't show up. That's square root of 2. Just in case we need it. And actually, we need it now, because g prime of 2 is going to be that square root of 2 that we just filled in. Now right here, f prime of 5, so that's pi, according to the table. So we have pi times square root of 2 as our answer for this. So notice what it really requires you to understand is how to use the chain rule. When you don't have a specific function, like a polynomial function or a trig function, you have a very generally expressed function, and you really need to understand how the chain rule goes. So let's look at another example. In this case, the function h is now still a composite function, but the other way around. It's now g prime, or g of f of x. So once again, in order to find the derivative of h is going to require use of the chain rule. So starting on the outside, we'll start with g prime, and we're going to keep that as f of x for now. Remember, it's one derivative at a time. And now we need to multiply by the derivative of f of x, which simply is f prime of x. So remember, we're trying to find h prime of 2. So let's just fill in our 2's for our x's. Alright, so let's start on the inside right here. F of 2, and that is defined to be 5. So it means on the next step we're going to need g prime of 5. F prime of 2, that's e. So this part right there is e. Now going back to the table, g prime of 5 is 7. So we have 7 times e as our answer. Now in this last one, we have the function h to be defined as f of x. So we start on the outside. So we have f prime of f of x, remember one derivative at a time. Now we multiply by the derivative of the inside function. So remembering that we want specifically to find h prime of 2. So from the table, and we'll start right in here at f of 2, so that is equal to 2. Oh, that's 5, I'm sorry. So we have f prime of 5 times, now f prime of 2 is e. So going back to the table once more, f prime of 5 now is pi. So we have pi times e as our answer for this.